بسم الله الرحمن الرحيم رب زدني علما.
Okay, the next thing we'll see what is NAT exactly. As I said, NAT stands for Network Address Translation. It's a process of translating your private IP addresses to get translated into a registered public IP addresses. Like I already said an example. So mostly in the production scenarios nowadays, to minimize the wastage of the IPs. So let's say I have hundreds of users or thousands of users. So internally within the organization, we'll be using a private IP. But when the traffic is going from my LAN, when it is reaching the internet or when it is leaving my router, then basically the source address will be translated to a public IP address. So which means if you take this example here, let's say this is a client which is using the IP address of 10.1.1.1, and this client is using the source address and it is trying to access a website on the internet, let's say cisco.com. Let's say assume the IP address of this public server is 170.1.1.1. So normally when the packet travels, generally the source address, you will have a source address is 10.network and the destination is 170. That is your actual cisco.com website. So when the traffic is leaving, so it comes with this address. When it hits this router, then this router is going to translate the source address. So the source address of 10.1.1.1 will change to some public address, and this is actually the translation to 200.1.1.1. So which means when the packet is leaving the router, the source address is replaced with 200, which means now the source address is 200.1.1.1 and the destination remains the same. So the destination address is the actual server. And then it leaves, because by default these addresses are private and they are not recognized on the internet. So when the traffic leaves and reaches the server, and when the server is replying back, so basically it's going to reply back to this destination, that is 200.1.1.1, which is the address used for this host, the private address. And once it hits back the NAT router again, when the traffic is returning back, again it will translate this public address into a private address again and route the packet to the actual host, of course to the switch and then to the actual host. Okay, so this is what NAT, the packet flow, we'll see anyway when we get into the configurations. And why we do this? Because the public IPs are private IPs, which is refined in the RFC 1918. Basically, these addresses are not routable on the internet. So by default, the service provider have a policy like they filter the routes which are coming with anything in the range of private IP addresses. Because normally IP addresses are usable, but default policy will not allow those routes. Again, in order to communicate with the internet, we need to have a registered public IP addresses. So if you want to connect to the internet, there are two solutions. Either you use a public IP and then translate the traffic without any NAT, or just simply send. And practically in today's networks, we'll be using a private, but when they leave the router, we are going to translate them into the public IP addresses. So next thing, what are the devices we can configure the NAT? We can configure them on the routers. So the NAT device can be a router, a Cisco router or any other router, or it can also be a firewall. You can also configure the NAT on the firewall. Like generally in most of production scenarios, you still have a firewall. Basically that is your edge device, and then you translate here instead of here. You can do that. Or it can be also on a server operating system. Like you can, in small companies, what you can do is you can configure a server with two NIC cards, basically one NIC connecting to the LAN and another NIC. So you can make this device as a NAT. So this is more applicable in the small size organizations where you don't want to use a dedicated router or a firewall. In that case, probably in our CCNA topics, we'll be seeing how we can configure the NAT on the Cisco iOS routers. But again, probably if you're going with CCNP security concepts, then basically you will also see how you can configure the NAT concepts on the firewalls as well. And again, as I said, it allows enterprises to use the private IP addresses, which means within the LAN, we'll still be using a private IPs, and then still we can access internet because of the translation of the private IP to the public IP. Okay, Again, as I said, NAT will change the source address. Like in our case, the source address is changed from 10.111 to 200.111 in this example, which I have showed in the picture here. So the next thing we'll see, what are the different scenarios we use NAT. Of course, one of the main scenario, as I said, to mitigate the IPv for address reflection, what we'll be doing is we'll be using a private IPs in our LAN. Let's say I have thousands of users and I can use a private IP address, and when they get translated, I can use one single public IP also. So with the help of Pat, we'll see that example as well. So that is one of the main reason we use NAT, because we don't want thousands of public IPs here. I just want to translate with a one single public IP. That is one reason. And internally, maybe you want to use internally a private IP addresses. That is one more reason, again, in this case. And other possibilities is like when you're translating, you also get some kind of security, because whatever the internal networks we are using, that will be hidden. So it adds some kind of security as well, increases the security by hiding your internal network. And the other possibility is if you have some kind of overlapping networks within the organization or while merging with other organizations. Like you can take an example here, like let's say there is a company ABC, and this company ABC is using some network 10.10.13. subnet, and this company merged with some other company, let's say XYZ. So these two companies merges normally, let's say, because within the company you have the same overlapping networks, or the same networks is rare actually. So maybe designing issues in that case, but generally let's say these two companies merges. Now when they decide to merge, then they realize that they are using some kind of private network here in both the companies, and both are using the same network, let's say. But now you still want to communicate between these two. In that case, what I can do is instead of changing the IPs, we can translate these addresses. When they go from here and reach, they can use some other subnet, let's say 150.subnet. And while these users, when they communicate with this one, they can use 160.subnet, something like that. So basically at the back end, they are using the same subnets, but when they are trying to talk to each other, they're using some different subnets. So that is another reason where in the kind of advanced scenario where you may see the NAT translations required. But the most common scenario, as I said, you are hiding your internal servers or internal addresses, and or the private IP addresses should get translated to a public IP. So we'll see it in the different types of NATs in the next examples.